Next question is, which is the major constituent of biogas and compressed natural gas? CNG. CNG, the abbreviation stands for CNG. CNG is compressed natural gas. CNG means compressed natural gas. So therefore, the chief constituent of biogas and CNG is methane gas, which is a marshy gas. So this methane is used as a fuel this is a domestic fuel, I am telling you. This is used in CNG, that is compressed natural gas. Now coming to the halogenation, is a chemical reaction that involves the addition of one or more halogens to a compound or material. The pathway and stoichiometry of halogenation depends on the structural features of functional groups of the organic substrate as well as the specific halogen. Halo means salt, gen means generator. Halogen means salt generator, my dear friends. So whatever the halogens are there, they are all salt generators. Example, fluorine, chlorine, bromine, iodine, etc. So therefore, the fluorine is the highly reactive element. Fluorine is a gas. Chlorine is also a gas. So therefore, chlorine, bromine, this chlorine is a gas. Bromine is a liquid. This is iodine. It is a solid. The speciality of the chemistry is halogen salts are different things. Therefore, halogenation is a chemical reaction that involves addition and one or more halogens. For example, chlorination, bromination, iodination, etc. This is a very important factor that halogen acts as a predominant role in the organic chemistry. Well, question number 30. Explain the nature of covalent bond using the bond formation of methyl chloride. My dear friend, the tetravalency of carbon, when the chlorination occurs during the process, the chlorine combines with methane in the presence of sunlight, gives the reaction, substitution reactions. For example, here chlorine reacts with methane, gives methyl chloride, or it is also called as IUPAC name chloromethane. So similarly, the bond between the carbon atom and each of the hydrogen atom is also covalent bond. What is covalent bond? It is nothing but the covalent bond between carbon and hydrogen. Similarly, there are other reactions here. Ethylene, this is unsaturated hydrocarbon, double bonded hydrocarbon, reacts with bromine, gives addition reaction, that is 1,2-dibromoethane. It is colorless. 1,2-dibromoethane. This is the nomenclature of the IUPAC system of naming organic compounds. So question number 42, what is catenation? Mention the different ways in which the catenation can occur, or describe the catenation by giving suitable examples. The straight chain structure, branched chain structure, and closed chain structure. So this is very important. Branched chain is nothing but isomer structure. Straight chain is nothing but the long chain structures of hydrocarbons. Closed chain is nothing but cyclohexanes, or it is also, we can close the chain. Benzene ring is also comes under aromatic hydrocarbons, or also comes under closed chain. So halogenation, as I told you, is the replacement of hydrogen atom by a halogen atom in a molecule. Halogens is a group of names that are given to the fluorine, chlorine, bromine, and iodine. Since these elements have a very similar behavior, they are often treated as a group. The term halogenation can thus refer to replacing any number of hydrogen atoms with each and any member of the group. The product resulting from halogenation will have quite distinct properties from straight compound. Example, methane is a gas that burns easily. If you chlorinate, halogenate, chlorinate means halogenate, that is chlorinate means addition of chlorine. Brominate means addition of bromine. Iodination means addition of iodine, like this. You get different substances like methyl chloride, methylene chloride, chloroform, and carbon tetrachloride when you are going to add chlorination on methane. These are called substitution. The reaction is called substitution reaction, and the products are substitution products. The completely chlorinated compound CCl4, that is carbon tetrachloride, is a strong degreasing cleaning fluid with a bad reputation for doing harm to the liver and kidneys. Very, very dangerous. Chloroform is very dangerous. There are several processes to halogenate carbon compounds. One other group of products are the result of mixed halogenation. Different halogens are used, for instance, chlorine and fluorine. This leads to the chlorofluorocarbons. Addition of that is called chlorofluorocarbons, of which carbon tetrachloride, that is trichlorocarbon and fluorocarbon is just one example. They affect ozone layer. So carbon, that is chlorofluorocarbons, are very dangerous, which affects the ozone layer of the atmosphere. Why their use is highly restricted. We should restrict all these things to safeguard our ozone layer, my dear friends. Next, coming to the methylation, this is the reaction mechanism is given in the slide. CH4 chlorination in the presence of sunlight, that is UV radiation, that is H nu E is equal to H nu, which indicates the in the presence of sunlight, this is methyl chloride and hydrogen chloride is liberated. Similarly, ethyl reacts with bromination in the same condition, gives ethyl bromide and the hydrogen bromide. Similarly, benzene undergoes in the presence of ferric chloride or aluminum chloride. In the presence of bromination, benzene ring undergoes bromobenzene. So these are the very important reactions. Thank you for listening. Have a nice day. If you like our video from ABSM Academy, like, share and subscribe. Don't forget to press bell icon and subscribe.